Okay, y'all, so we're going to switch it up a little bit today. We're going to do the quiz after the notes. Okay? Today's notes are pretty short, and really, there's really nothing very new that I'm going to go over with you today. But I really want to make sure that we understand the relationship between the graph of the derivative and the graph of the original function. There was one problem on your homework, a couple of y'all asked me about, where the graph of the derivative was given, and you're asked to tell me what's happening with the function f. And this is not something that we really went over explicitly in the notes last time, so I want to make sure that we go over this before I give you a quiz question on it. So we're going to go over the notes first. It'll take like 15, 20 minutes tops, and then we'll take the quiz for today. So let's take a look at this graph here. We're still working with the first derivative test, which, just as a reminder, is a tool to help you analyze a function when you're given a derivative. So with the information that we can get by constructing that sign chart, we can say where the function is increasing and decreasing, and also identify relative extrema. So let's take a look at this graph, and this is not a graph of f. This is a graph of f prime. So what this graph is describing, all the y coordinates on this graph describe the slope of the original graph. So what I want to do is create a little number line chart here with all the values that are going to be key. We've got -9 and 10, 9 is our endpoints here. And basically just kind of reinterpret what we're seeing over here, but only picking out the pieces we really care about for this type of analysis. So previously, I would give you like an equation or a graph of the original function, and you would differentiate it, find the critical points, and then use that sign chart to determine the intervals of increasing, decreasing. Where here, you're actually given a graph of the derivative already. So what we're going to do is interpret the key pieces of this graph and try to determine what's actually happening with f. So one thing to notice here is we've got several x-intercepts. Right? We've got one at -7, -2, 2, and 8. Right? These are all x-intercepts. These are locations where the slope is 0. Okay, that means that on the original graph, you have a horizontal tangent line. So anywhere where we see these x-intercepts, those are your critical values of the original function f. So those are going to be the numbers I put on this number line to partition it out and basically split up. Split up the domain into intervals where we can decide if it's increasing versus decreasing. So, and this number line, again, this is f prime, not f. Okay, so what I might also do here is construct a number line just to kind of start to be thinking like this with these exact same x values. So we can at least start to piece together this connection between the two graphs. So wherever I have an x-intercept on the derivative, this represents a critical value. That doesn't necessarily mean you have a relative extrema, but that if we do have one, that's where it'll be. We also have intervals here where the slope or the derivative is either positive, meaning like above the x-axis, right, like here and here. And we have some intervals where the slope or the derivative is negative, here, here, and here. Okay, now I don't have to like pick representatives and plug them into the derivative equation to find out the sign in all these intervals. I can just look at the graph and say, okay, well, between -9 and -7, the derivative is positive. Okay, it's above the y-axis. And so when the derivative is positive, what does that tell us about the graph of the original function? It's increasing. The slope is positive. So like if we're trying to envision what's going on with that graph, in this interval, the slope is increasing. Okay. In the next interval, the graph is below the x-axis. That means that the derivative or the slope is negative. Right? So on the original graph f, even though we're not really ready to sketch that out yet, we'll get there eventually, but at least at a baseline, we know that the slope in that interval is negative. So the function is decreasing in that interval, right, of the original graph. Now between -2 and 2, the derivative is still negative, right? So the slope of the original graph is still decreasing. And so what's probably happening at -2 is we've got this bendy behavior, kind of like y = x cubed, where the graph is going to, maybe if I try to connect these, is going to be, have a negative slope, kind of, what do I want to say, like flatten out so that the slope is 0, but then go back to being negative. Right. Then between 2 and 8, the slope or the derivative is above the x-axis, so the derivative is positive, meaning that the slope of the original graph is positive. And finally, between 8 and 10, the slope is negative, so the original graph is decreasing. Okay, so if we're looking at, the sign chart versus like our little crummy little sketch of the original graph, we can see where the function's increasing, decreasing pretty clearly. We can also see where we have maxima and minima. We've got one maximum at -7 because the slope is changing from positive to negative. We have another maximum at 8 for the same reason. The slope's changing from positive to negative. And we also have a minimum at 2. So now we're ready to answer all these questions. It says, number 1, determine the critical values of f and classify them as being maxima or minima or neither. So the critical values of f, just to kind of remind you of the definition of what that means, these are the values, right here, I'll write it up here. Okay, values that make the derivative either 0 or undefined. In this case, there's no sharp corners or anything, so it's never going to be undefined. So all of the values that we see here, we have a critical value at -7, -2, 2, and 8. So basically all these values, these are our critical values. So we'll just write them out here. We got one at -7, which we said was a maximum. We also had a maximum at 8. We have a minimum at x = 2. And we do have another critical value, but it's not going to be a max or a min. At x = -2. Now, the way we know that there's going to be a maximum or a minimum at these critical values is based on how the slope changes. Okay, we have a maximum because the derivative went from being positive to negative. All right, slope's going up, and it comes back down. Similarly, we know that there's a minimum at 2 because the derivative went from negative to positive. We know that at -2, even though there's a critical value, it's not a max or a min because the sign of f prime didn't change. Any questions about these maxima and minima and how to justify your answers? Okay, so those were all the critical values and what they represent. So now let's list the intervals of increasing and decreasing. So I'm going to have to kind of scroll back up to see because I don't really remember. Okay, so we're increasing between -9 and -7, and also between 2 and 8. So we're increasing on the interval -9 to 7, -9 to -7, but also 2 to 8. We're decreasing, try to squeeze this on here, on the interval -7 to 2 and 8 to 9. Now, as far as describing how you know, well, we know where we're increasing and decreasing based on the sign of the slope. So we know we're increasing in those intervals because the derivative is positive. And we're decreasing on these intervals, -7 to 2 and 8 to 9, because the derivative is negative. Okay, so here is where I'm going to push you a little further. All the rest of that is like pretty much review, other than the fact that I'm giving you the graph of f prime versus the graph of f. So it says if f of 6 is -2, determine the equation of the line tangent at x equals 6. Okay, so we're going to go through our point slope template here. Right, we have a point which is actually given. We don't have to find the y value because it was given to us. The point is going to be 6, -2. But what's the slope at x equals 6? So let's go back up to this graph. Okay, so again, this is the graph of f prime, not the graph of f. So if I want to know the slope of f when x is 6, I'm going to look at where x is 6 and report back the y value of the derivative. The y value of this function here describes the slope of the original function f. So the slope of f when x is 6 is 3. All right here. So the slope's just going to be 3. And now that we have everything, we're good to write our equation. Y plus 2 equals 3 times x minus 6.
That's what it's tangent to. Right? No,
that is the equation of the line tangent to the original function. Now, in order for the line to be tangent, two things have got to be true. It has to intersect the original curve, which is what it is doing at this point, but it also has to have the same slope as the original curve. Yeah. The normal one? Yeah. So we don't have to worry about that, right? Because this one's not asking about the normal curve, normal line. Okay, the last question here is to determine the value of the second derivative at 4. And this is something we're going to revisit next class, next week, when we talk about the second derivative test. But for right now, we're not going to get really too deep into that. I just want you to be able to find this. So the second derivative represents the slope of f. So if I want to know the value of the second derivative at x equals 4, I'm going to find the slope of that curve of f prime when x is 4. So if we look back up here and we look for where x is 4, what is the slope of the curve when x is 4? Like, what's the slope of f prime? 0, right? It's got a horizontal tangent line there because we have a local maximum, right? So the value of f double prime of 4, or the value of the second derivative at x equals 4, is 0. It's the slope of the slope, yeah, or the rate of change of the rate of change. All right, that's it for the notes for today. I told you it was going to be a pretty short one, but I just want to clarify these kind of problems for you. We're going to take our quiz, and then once you're done with the quiz, I'll give you your homework, and that's really all we're going to do today. Okay?
Is this quiz going to be as long as the last one?
It's a page. Yeah, I don't.